Okay, the next problem I'm going to look at is practice problem 4 on page 221. And this problem here, you have Joe as a tinkerer, and he makes a claim that he can have a heat engine produce 1 BTU of work, British thermal unit. So these are just the USCS units, or one of the units that's used for energy. And he gets 1 BTU for every 2.5 BTU of heat that it receives from boiling water. Okay, and what we want to do is, so then Jane informs Joe that he intends to design heat engines. He needs to pursue engineering education first. And the reason is because, um, according to Jane, his thermal efficiency is impossible. Okay. So what we need to do for this particular problem is we need to calculate the thermal efficiency, at least the claimed thermal efficiency, and also we want to calculate the Carnot efficiency. The Carnot efficiency is the theoretical limit, right? So that's the highest. The Carnot is the highest efficiency you could possibly get under these conditions with the temperatures that he's defined, which Joe has defined for his system. So what we'll do is we'll look at the theoretical best efficiency and we'll compare it to the claimed efficiency. Okay, continuing on with practice problem number 4. So we have, what are we looking for? Determine if the stated efficiency is possible, okay? What Joe had stated as his efficiency for his heat engine. So we have a high temperature. This is the source, okay, of the heat. Here is our sink for our heat. Here's the work out claimed, and here's the work in, okay, for the defined work in. This is the claimed work out for the defined work in. Okay. Governing equations, we have, this is the actual, or if you want to think about, this is the claimed efficiency, okay, and this is the Carnot efficiency, right? So this is the claimed efficiency. We're going to use this equation for the claimed efficiency. And here's the Carnot efficiency. There's a couple things. One thing is this is the theoretical limit, okay? You can't get any higher efficiency than the Carnot efficiency for a heat engine. One of the notes, temps must be in degrees Kelvin, or in Kelvin, okay? And here's the actual calculation to get that, to convert from degrees C to Kelvin. So first part is, for the solution, I went through it and made the conversions for the input and the output. This is actually, you could say the input is really just the high temperature, and here's the low temperature, okay? I used a different notation here, but this is essentially the same thing. This is our high temperature, and this is the low temperature, okay? Okay, continuing on with the practice problem 4, second part. So we calculate the Carnot efficiency, which is just a low temperature in degrees, or in Kelvin. And here's the high temperature. So this is the low temperature sink temperature, and here's the high temperature sink temperature, and that comes out to be 0.282. Here's the claimed. So I just used the actual equation for the claimed, right? And here's the claimed. This is the amount of work being done out for 2.5 BTU in, and the claimed is 0.4, thermal efficiency. Now, comparing these results, what we see is that the claimed is higher than the theoretical limit. So this is not possible. All right. So yes, Jane is correct. And just a final note here, the M thermal efficiency is, this is the theoretical limit. Okay. And that's it.